here we are starting a new chapter in our lives. Isn't that exciting? Well, this chapter is all about quadratic equations, or quadratic functions. And if you've never heard of a quadratic equation or quadratic function before, all it is something of the form ax squared plus bx plus c. So we've seen those before. We learned how to factor those and everything. We've seen them a lot. But we're really going to focus on those guys. And in this section and in the coming sections, we'll be really focusing on how to solve quadratic equations. Some of them we already know how to solve, like by factoring, but there'll be some where you can't factor, and we'll have to think of other ways to try to solve them. So in this box at the top here, it kind of tells you, why do we care about solving quadratic equations? What's the importance? Of course, we saw applications of it in the factoring section. We know that there are applications of factoring, but I guess further in math, what we want to do is be able to graph any function of that form, ax squared plus bx plus c. We want to know what its graph looks like. And as it states here, the graph's shape is going to be what they call a parabola, which you see in the picture there. It looks like a U shape kind of. But what you don't see is that the graph goes up forever. There should be arrows here at the edge. It goes up forever. It's kind of like, a sort of a U shape or a V shape because it's kind of pointy. But in order to graph them, we kind of want to know, depending on the specific quadratic function, how high or low does that shape hit the x-axis, how high or low does it hit the y-axis, and also how wide or how narrow is the shape, because depending on the quadratic function we're given, it could be a really narrow parabola or a really wide one. So we kind of want to figure out all the characteristics of it. And so as it says here, where is it? Here it says the solutions to f of x, this function, the quadratic function equals 0. So if you set your quadratic function equal to 0, it's now become an equation because there's an equal sign. What that corresponds to as far as the graph goes is the x-intercepts of the parabola. So if you can solve that equation, you're actually finding out where this parabola hits the x-axis, which is very useful because imagine you found out these 2 points here, the x-intercepts. That kind of tells you how wide or how narrow this thing is, right? If those x-intercepts are far away from each other, it's going to be wider. If they're closer to each other, it's going to be narrower. So it really tells you a lot about the graph, and that's why we care. So for example, just if you want to see a specific one, here we have, if you have this specific quadratic function, x squared minus x minus 12, you can find the x-intercepts as they describe by setting it equal to 0 and trying to solve. Well, luckily, that's something that factors. That's x plus 3, x minus 4. So not too difficult. If it didn't factor, that's what we're kind of gearing up towards in this section, seeing what to do about types of quadratic functions that can't factor. But once you factor it, then, as we've seen before, you set each factor equal to 0, the left factor equal to 0, the right factor, and then if you solve the one on the left, of course you'd try to solve it by subtracting 3 from both sides. So you end up with negative 3, and that's why you have this x-intercept at negative 3. And here you would add 4 to both sides to find the second x-intercept at x equals 4. And that's why this x-intercepts at x equals 4. So this is kind of why we care about the solutions. So it's kind of easy to get lost in all the math that we learn and don't, kind of forget why we care. That's kind of why we care, and that's what we're gearing up towards. That'll be what we'll see in kind of towards the end of this chapter, is graphing parabolas. All right. So first thing, we're just going to start solving things that we might already know how to solve. Like this first example, let's try to solve x squared equals 49 by factoring, because that's really the only technique we have under our belt so far. So we have x squared equals 49. If we want to factor, like we've seen before, you need to get everything on one side first, and then we'll try to factor it. That's x squared minus 49 equals 0. Okay, and that's actually a difference of squares, right? That would be x minus 7, x plus 7, or vice versa. All right, I'm running out of room, so let me rewrite it real quick. X minus 7, x plus 7, okay. And now I'll set each factor equal to 0. This guy and this guy. If I solve the left one, I'll add 7 to both sides, and I'll get x is 7. Here I'll subtract 7 from both sides and get negative 7. There we go. So these guys have two solutions, actually, 7 and negative 7. If in this problem the first thing you thought of was, oh, you know what, if I want to solve this, why don't I square root both sides? You're right, that's what we're kind of getting towards, but notice, if you square root both sides, the square root of x squared is x, but the square root of 49 is 7. And you would have missed one of the solutions there. It's not just 7, but also negative 7. So you got to be a little bit careful. You're going to have two solutions to all of these. And that's why they make a really big deal out of it when they point it out here. Oops. Where is it? They call it the principle of square roots. That basically, if you're ever solving an equation that looks like x squared equals something, the solutions aren't just the square root of that number, it's also the negative square root of that number, like we saw up here. So you've got to be a little bit careful. And for that reason, a lot of times when you see people solve it this way, they square root both sides of the equation, they'll usually put what they refer to as a plus or minus here. So that's good to keep in mind. I might write that here. When you square root both sides of an equation, you know when you're solving it, you have to place a plus or minus next to the number. That should be, so after a while we'll notice that'll be an automatic thing. We'll just do that without even thinking because we'll do it so often. But that's something you want to really keep in mind, because if you don't put the plus or minus, you'll think there's only one solution, the positive one, when there actually, when there are actually two solutions. So be a little bit careful on that. It's kind of tricky. But we'll do so much practice that you'll get tired of it. So okay, let's see. For example 2, we've got a few problems here. I guess now since we're using the principle of square roots, now we don't have to factor. We're going to isolate the square, or what's being squared. Isolate the square, then root both sides. I'll even add, don't forget the plus or minus, because it's easy to forget that part. That's how we're going to tackle all these. So in part A, if I want to isolate what's being squared, that's the p. So this 50 needs to move over. You want to isolate what's being squared, and that way you can square root both sides. Then we'll have p squared equals 50. Now I'm ready to square root both sides. Okay. Square root this guy, square root that guy. On the left, the square root and the square cancel. On the right, don't forget your plus or minus, like we said. Square root of 50. And that you can simplify. If you use the techniques from the previous chapter, that's 5 root 2. If you split it up, factor 50 into primes and all that kind of stuff. So really, that's our solution. It looks like one solution, but it's really two solutions. And that's why a lot of times in the homework, they ask you to write it as two separate solutions. 5 root 2 and negative 5 root 2. Just because I think they don't want us to forget that there are two solutions here, not just one. Alright, looks good so far. Let's try part B now. What do we have? Part B looks a little more complicated, but it's similar. I still want to isolate what's being squared. And here what's being squared is just the A. 36 is not being squared, it's just the A. I'm going to isolate A. First thing I would do is move the 25 over. Okay, and then we'll have 36a squared equals 25. I still don't quite have the thing being squared by itself, so I'm going to divide by 36, and then I'll be at that stage. So a squared equals 25 over 36. But now that I have this thing that's being squared all by itself, I'll square root both sides, like the square root principle, or the principle of square root says to do. On the left side, the square root and the square will cancel just to leave the a, but on the right side, don't forget your plus or minus. Square root of 25 over 36, and luckily both of those have square roots. So you don't have to write this step out, but remember you could square root the 25 and square root the 36 separately. So that means a is plus or minus, square root of 25 is 5, square root of 36 is 6. So there are your two solutions, but if they want you to split it into two solutions, it's 5/6, the positive one, and negative 5/6, the negative one. It kind of depends. I think a lot of times they like the two solutions separate, so keep that in mind. The plus or minus really means two things, one positive and one negative. Alright, so far I think we're doing good. We're just going to kind of try to make these a little more complicated as we go to get ready for the last part of this section. Alright, on part C here, you notice that the entire left side is being squared. So what's being squared is already isolated. I'm just ready to square root both sides right away. Even though it looks complicated, it's x plus 1 squared. The entire thing's being squared. So the square root and the square will cancel. Just to leave what's inside, the x plus 1. On the right side, don't forget we said put a plus or minus next to the number. And I guess by number I mean not the side with the variable, the other side, the side that just has a number, no variable. So So, and of course, the square root of 100 is, excuse me, is 10. So we have x plus 1 equals plus or minus 10. And this is where you've got to be really careful, because now x isn't quite by itself. I need to move the 1 over. So x is, and this is where I might be careful, because this isn't like plus or minus 10 subtract 1 is not plus or minus 9. So what I would do is just write it as is for now, plus or minus 10 minus 1, and then split it into the two solutions and try to simplify separately. Because you know, plus or minus 10, that's two different numbers. That's 10, and you're subtracting 1, but it's also negative 10, and you're subtracting 1. You're not going to get plus or minus 9. So you got to be careful. Plus or minus 10, it's two different things at once, so you can't really do arithmetic with it. So on one hand, this is 10 minus 1, which is 9. But on the other hand, we're going to use the negative. It's negative 10 minus 1, which is negative 11. So if I had said that here plus or minus 10 minus 1 is plus or minus 9, I would have been wrong, because I don't have a negative 9, I have a negative 11. So really, you got to be really careful. You can't really do arithmetic with a plus or minus. You can't combine that with something else. You have to split it into its two meanings, or the two solutions, and then you can do some kind of arithmetic when they're two separate things, not one combined thing. So let's try part D. This one I think is pretty similar. What do we have here? Again, like in part C, the thing being squared is isolated, so I'm just going to go ahead and square root both sides to cancel that square. So the square is gone from the left, just the 2z minus 3 is left. On the right side, I can't forget my plus or minus. And this is where I see, there's a negative inside a square root. So that means it's imaginary, right? But remember in the previous section, the end of the square root chapter, we saw that this can be written as something in terms of I. So remember, you get rid of the negative, so I'm going to write it as positive 49, and you throw an I on the end. That was the very first thing we learned in that last section. So if you have to go back and review that, that was the very first thing we learned. Remember, you can always rewrite any imaginary number in terms of I by replacing the negative that's inside the root with an I outside the root. That was kind of the easy way to remember it. All right, and then of course, now that I just have a positive 49 inside a root, that's 7. And then I'm almost done. I just need to kind of solve for z. Let me move this 3 over here first. That way 2z is, and you can't combine those because you have a plus or minus 7i. That's two different things at once, plus 3. So I have to leave them separate. And then my last step is to divide both sides by 2. There we go. So z is pretty much what we have on the right side, plus or minus 7i plus 3 over 2. And of course, the homework, they'd like you to split that into the two solutions. So I'm going to rewrite this statement with a positive for 7i here. Everything else stays the same. And then once with a negative for 7i, but everything else stays the same. And if there was anything I can combine there, I would try to combine it, but 7i and 3, they're not like terms. So that's really all you can do. Those are your solutions. That's pretty much the ugliest solutions you've ever seen, but hey, what are you going to do? There they are. Alright, this stuff's kind of weird, and at this point I kind of wish I didn't know about imaginary numbers, because now they're making me deal with them, you know? Isn't that true in life? The more you know, the more people make you do. It's like at your job. Everything you learn, you're expected to do it from then on, so don't learn anything. Just kidding, but seriously. All right, how about part E? Now, this is getting a little more interesting. We have, remember we want to isolate the thing being squared. And here the thing being squared is this x minus 5. So I do need to move this 4 over first before I try to square root anything. That way x minus 5 squared, the thing being squared is all by itself. Over here, 12 and 4 make 16. All right, now I can square root both sides. Because now the square root and the square will cancel. Gotcha. So x minus 5 is all that's left. Don't forget, though, on the right you need a plus or minus. That's easy to forget. And then, of course, the square root of 16 is 4. Plus or minus. And if you're wondering, well, which side do I put plus or minus on? Just always put it on the side that doesn't have a variable. And now we can solve for x all the way by moving that 5 over. Add it out of the way. And I got to try not to be tempted by combining this plus or minus 4 plus 5. Plus or minus 4 plus 5 is not plus or minus 9, because plus or minus 4 represents two different things. So I'll leave it like that, but then I'll split it into the two solutions. One of them will be where 4 is positive, and the other one will be where 4 is negative. But notice the sign of the 5 doesn't change. It's only the 4 that had the plus or minus, so he's the only one that has the changing sign. So on this side, that makes a 9, but over here that makes a 1, right? So it really would have been wrong if I had put plus or minus 9 when I tried to solve for x here. That's interesting. 9 and 1 are the solutions. Huh. Nice numbers, huh? Not like that last problem we did, were really ugly answers, weren't they? Ugh. So you never know. Sometimes the answers are really nice, like 9 and 1. Sometimes they're really bad, like the last one, 7i plus 3 over 2. What the heck is that? Anyway. Alright, let's try this last one, and then I think we're doing good, and we'll be ready for the last part of this section. So again, you want to try to isolate what's being squared here, which would mean I didn't need to move this 3 over, because everything else on the left side, other than the 3, is being squared. This whole 4m plus 1, that's all being squared. On the other side now, 28 minus 3 is 25. There we go. And now that what's being squared is isolated, I can square root both sides to get rid of it. That'll cancel the square there. And then the 4m plus 1 will be all by itself on the left. On the right, do not forget your plus or minus. And the square root of 25 is 5. There we go. Now that the square is gone, we can start isolating m. First I'll move the 1 over, but I'll try not to be tempted to combine that 1 and the 5. Because remember, this 5 is not just one item, it's two items. It's 5 minus 1 and also negative 5 minus 1. And I'll deal with it later. I think what I like to do is isolate the variable all the way, and then try to figure out what all the solutions are. So divide by 4 to isolate m all the way. It means m is plus or minus 5 minus 1 over 4. Then I'll split that into the two solutions. So here, one solution will go here, the other one will go here. One with the plus and one with the minus. So in one case, 5 will be positive, everything else stays the same. In the other case, 5 will be negative, but everything else stays the same as well. Okay, if I simplify this first one on the left, 5 minus 1 is 4 over 4, which is 1. And the other one I have negative 5 minus 1, that's negative 6 over 4. That reduces to negative 3 over 2. Alright, so those answers aren't too terrible either, are they? I guess part D was the worst. Oh, got some imaginary numbers, some ugly. Oh wow, so this is getting pretty complicated, these problems, huh? But alright. Those are fun, but let's see. I guess the idea now is, if you look back at those, 6 problems we just did, they all kind of had the form where you could isolate the variable. I mean, the variable was being squared everywhere, like, in the first problem, it was just p squared. The second problem, it was a squared. The third one, x was in the parentheses with 1, but it was all being squared. And then the third one, you have 2z minus 3 squared. So in all these problems, we can kind of isolate the variable, but we take the square root to get rid of the square. But still, we isolate the variable, take the square root, and we were good. But think about, for example, in this third example here, part A, I can't do that with this example, x squared plus 10x minus 2. Because this one's different than the previous ones, because I see x squared here, but I see an x, so there's two separate variables. And they're not like terms, so you can't combine them. But if you look back at those 6 problems we just did, the variable only occurred in one spot. Like here, p only occurred once, x only occurred once, a only occurred once, m only occurred once. So when you only see your variable once, even if it has a square around it, it's not a big deal because we just figured out how to do it. But now the problem is, what if you see an x squared or a variable squared and your variable? So you can't really isolate the variable. So we can't really do what we did just now. And the only other way we know how to solve these is factoring. But it turns out that this guy in part A doesn't factor. Because imagine you try to factor it. This would be an x and an x. You'd want the numbers that multiply to negative 2 but add up to 10. There are no such numbers, so this thing doesn't factor. So we must need a new technique on these. So the idea with these problems is, okay, if it doesn't factor, and I can't use the method that we saw above in the previous example, maybe we can make maybe we can make the problems we're given here look more like example 2 problems. That's really the idea here. So all these steps that we're going to learn just right now to solve these guys, this is us trying to make all the example 3 problems that we're about to see look more like example 2 problems. So that's kind of the idea, like in part A, I kind of want to make this look like x, maybe something else in the parentheses, like x plus something or x minus something squared equals a number, you know? Because then if it looks like that, that's something I can solve with the previous method. I can just square root both sides, isolate x, yada, yada, yada. So that's why they call this process completing the square, because you're trying to make this look more like something squared so that you can solve it like the previous method showed us. So this method it's pretty long, it takes a while, and it's hard to memorize, so bear with me. This is definitely, right off the bat, this first section in this whole chapter is the hardest section, and then it gets easier from there. And the reason it's tough is because these steps are seemingly random, and there's a lot of steps that you have to memorize for this process. But the more of these we do, that's why I kind of tried to have 6 examples here to really drive it home. The more of these we do, the better we'll get, so let's see. Might as well jump into it. Let's try example 3 part A, following these steps. The first thing they say, step 1, isolate the terms with variables and write them in descending order of powers. So I look at part A here and I notice they're already in descending order of powers, but the terms with variables are not isolated because I see that this 2, he doesn't have a variable and he want to move him over. So you only want to see terms with variables on the left, like x squared, he has an x. 10x has an x, but the 2 doesn't have an x, so you want him to move over. That's your first step. And then the second step says, okay, well, if your coefficient of the leading term, which is x squared, the highest power, if the coefficient is not 1, you need to get rid of it by dividing every term of the equation by that number. But look at our coefficient of x squared, it is 1. So we don't need to worry about it. If there's no number in front of x squared, that means the coefficient's 1, and there's no problem, and you can skip step 2. But if there was a number in front of x squared, like, I don't know, 3, then you'd have to do that step, like it says, you divide everything by 3 to get rid of it. But we're kind of lucky in this case, we don't need to do that. So we can skip step 2. And now step 3 is kind of funny. It says, find the magic number. Because what we're doing now is there's going to be a certain magic number, I call it magic, that you're going to add to the left side of the equation. You know, it's going to be plus something, so that the left side will factor into a perfect square. Because that'll be us completing the square, like the title says. And it'll make this problem look more like the problems from example 2, which we actually know how to solve. That's what we're doing in this step is, trying to find that perfect number that's going to make the left side factor into a perfect square. So I usually do that off to the side. I'm going to find the magic number. And you won't probably see that in the math book. I made that up, magic number. I think this number doesn't have a name. They just say, find this number. But it's more fun when it's magical, right? Magic number, okay. So like it says in step 3, you're going to want to find half the coefficient of x. So let me see. In our problem, the coefficient of x is 10. So I want half of 10. Okay, we're going to find half of it, but then notice that it says, not only do you find half of the coefficient of x, then you're going to square the result. So when I'm done finding half of 10, I'm going to square that. And that's kind of what you're always going to do in these problems. Look for the coefficient of x, there he is, whatever it is, find half of it and then square it. So to help me remember, I always kind of set this thing up right here the same way. Bracket 1/2 of the number squared. So first I figure out what's half of 10. That'd be 5, right? Half of 10 is 5, and then I square that. 5 squared is 25. There we go. That's the magic number. And there's only one unique magic number, so if you mess up that process and you get a different number, it's not going to work. It has to be that magic number. Alright, so we did step 3. We found the magic number. Now, step 4 says, add the magic number to both sides of the equation. So I'm going to rewrite the left side. X squared plus 10x. And leave some space because I'm adding the magic number to that side. Plus 25. But also, to balance it out, you have to add it to both sides. It's kind of like scales, you know? If you have scales that are evenly weighted and you just put 25 pounds on one side, it's not going to be even anymore. But if you put 25 pounds on the other side, it will be even and the scales will be balanced. Alright, now we're ready for step 5. Step 5, we're almost done. it says factor the left side into a perfect square. So you're going to factor the left side, and it should factor into a perfect square. If it doesn't, you did something wrong. Maybe your magic number's wrong. So it'll be an x and an x, and you want to know what multiplies to 25 but adds up to 10. It'll be 5 and 5, right? 5 times 5 is 25. 5 plus 5 is 10, so that works. And then also in the same step, on the right side, you want to combine like terms. 5 and 25 makes 27. There we go. Then of course, as we've been taught, if you see two factors that are the exact same like that, x plus 5, you write that guy as x plus 5 squared. That's what they mean by a perfect square. Factor it into a perfect square. All right, now we're on the very last step. Basically, at this point, we've whittled the problem down to a problem that looks a lot more like example 2 problems. So now we know how to solve these. Looks like example 2, all those problems we just did, which we know how to solve. Yeah, so not too bad, not too tricky. Remember, when the example 2 we said you want to isolate what's being squared, which we already have, and then you want to square root both sides. So I'm going to go ahead. You can do it in that last step, but I'm going to do it in a separate step. Square root this guy, square root that guy. And don't forget, when you square root, you want to put a plus or minus next to the numerical part of this example. On the left, the square root and the square will cancel just to leave the x plus 5. On the right, okay, 27 doesn't have a square root, but it does simplify. If you use the techniques from the previous chapter, that's 3 root 3. And I'll isolate x by moving the 5 over there. And that'll pretty much be it. I've got x is what was already there, plus or minus 3 root 3, and then minus 5. And if they wanted two separate solutions, you'd write one with the positive, 3 root 3 minus 5, and then one with the negative, negative 3 root 3 minus 5. There are your two solutions. Whew! So that's a long process, but let's see. We'll keep doing it, and then I think you'll get the hang of it after a while. This really takes a lot of practice because the steps are so seemingly random and hard to remember, and you have to do them in the order they give them to you. You can't mix these steps up. They have to be done in that order, and you can't skip any steps or the whole thing will be messed up. So okay, let's do part B. First step was you only want terms with the variable on the left side, so I'm going to move the constant term, they call it, to the other side. That way there's only w's on the left, w squared plus 12w, and now on the right, negative 32. Okay, the next step said, if there's a coefficient of the leading term, which ours is w squared, if the coefficient's not 1, you have to divide the entire equation by it. But for us, we already have a 1 as the coefficient, so we can skip step 2. Skip it. The next step is finding that magic number, like we said. So I'm going to go off here, find the magic number. So remember, magic number, you take the coefficient of, well, I've said x up there, but of course we have a w. Our coefficient of w is 12. You want to find half of that, and then you're going to square the result. So half of 12, what's that? 6. We're going to square that. 6 squared is 36. Okay, so that must be the magic number there. All right, remember, yeah, whatever the coefficient of x is, or sorry, w in this case, 12, we're going to divide that by 2, or half it. Half of 12 is 6. Whatever you get, square it. 6 squared is 36. And then once you find the magic number, you're adding that to both sides. So I'm going to rewrite this, but I'm going to leave some space. Add 36 to both sides. Of course, add it to the left and to the right. All right. And at this stage, they say the left side should factor into a perfect square. So what multiplies to 36 but adds up to 12? That would be 6 and 6. And the right side, negative 32 and 36 add up to 4. And on the left, we must have done something right because those two factors are the same. If they were different or it didn't factor at all, we did something wrong. But that's how I know we're doing something right so far. So w plus 6 twice makes w plus 6 squared. Now I'm going to square root both sides to solve it all the way. But don't forget the plus or minus on the right side. Plus or minus, okay, the square root of 4 is 2. Now we almost have it. Let me move the 6 over. And I got to be careful. I'm not going to say that's plus or minus 6, or sorry, plus or minus 2 minus 6 is plus or minus 4. That's not true. have to write it as is and then split it into the two solutions like we've seen. That's positive 2 minus 6. And the other one, 2 is negative, so negative 2 minus 6. This is negative 4, and this is negative 8. There we go. Those are the solutions. All right, let's try part C now. This is, again, these are all very similar. They're just kind of, I don't know, a little tricky, I guess. And it's hard to remember all the steps, but the more of these you try, the better you'll get. So, okay, part C, the first step, remember, is to isolate the variable. So since 25 doesn't have a variable, I'm going to move him over. Be x squared and 9x, only the variables on the left, 25 on the right. And then step 2, this one we can skip again because the coefficient of x squared is 1. We will see some where the coefficient of x squared is not 1, but in this case it is, so we're good. We can skip step 2, and now step 3 was to find the magic number. And this one, I think the magic number is not going to be pretty because, remember, you find half of the coefficient of x. In our case, the coefficient of x is 9. So that's a problem because 9 doesn't really have, you can't really half it very well. It's not pretty. And in these ones, I would advise you don't use decimals. Half of 9 is 4.5, but that's not really going to be helpful for these problems. Your answers aren't going to, they don't want you to have decimals in your answers. So what I'd do is think, okay, I'm finding half of 9, but when you find half of something, think of it as multiplying by a half. I'm going to put the 9 over 1 and multiply across. So 9 times 1 is 9, 2 times 1 is 2, so you're squaring that thing. You want to leave your answer as a fraction, not a decimal. So even though half of 9 is 4.5, I want to see that as a fraction, 9 over 2. And then square either one. 9 squared is 81, 2 squared is 4. There we go. So unfortunately, that's our magic number. That's what I'm adding to both sides. 81 over 4 on the left, 81 over 4 on the right. Terrible. On the left, there was already x squared plus 9x. On the right, there was already a 25. So on the left now, imagine you're trying to factor this. This is x and x. You want to know what multiplies to 81 over 4 but adds up to 9. That's kind of tricky, but you know what? The good thing is I can give you a little hint, especially for these times where the magic number is an ugly fraction. The number that goes in here, of course they're going to be the same number because this is a perfect square. This will be half the coefficient of x, which we found kind of halfway through the magic number. Remember, half of 9 was 9 halves. So that guy, it's like the halfway point when you're finding the magic number is going to be the number that goes in here in the parentheses. Yeah, because half the coefficient of x was half of 9, which was 9 over 2, before you squared it. So that way you don't have to do all the, I don't know, tedious math of trying to figure out how that factors. On the right side, I want to combine 25 and 81 over 4, so I better find a common denominator. Put the 25 over 1, multiply it by 4 over 4, it'll become 100 over 4, plus there was already an 81 over 4 there. So that'll add up to 181 over 4. And on the left side, since those are the same factor, I want to write it as that thing squared. And then we almost have it. If I square root both sides, I can start solving for x. The square root will cancel from the left side with the square. On the right side, don't forget your plus or minus. 181 does not have a square root, but 4 does. 4 square root is 2, so at least that's something. And then I can isolate x all the way by subtracting the 9 halves to the right side. Alright, and then we have it. It's not a pretty answer, but there it is. We already had the plus or minus 181 over 2, but now we're subtracting 9 halves. If I split that into two solutions, I have the positive one, 181 minus 9, and you know what you might do is see them, since these two fractions already have the same denominator of 2, you might see them write it over the same denominator. And same with the negative part. Negative root 181 minus 9 over 2. There they are. There are your two solutions. Terrible, but what are you going to do? Okay. Now let's look at this next example. I mean, it seems like a new example and the directions are different, it seems like, but we're actually really going to do the same thing. So step 4 says, complete the square to find the x-intercepts of the given function. But remember, from the very beginning of this section, we said the x-intercepts are found by taking your function. In part A, it was 9x squared plus 18x plus 8, and setting it equal to 0. So that's how you find x-intercepts. So I think they're just wanting to connect this concept of completing the square with the whole reason that we're trying to solve these things. So, but notice, once we set it equal to 0, it kind of ends up being a problem just like you saw in example 3, part A, or part B, or part C. So it's just one extra step of you having to put the equals 0. But that's really it. It ends up being the same problems as we've just seen in example 3. So once you say equals 0, set equal to 0, then you're doing the exact same steps as you saw in the completing the square steps. So completing the square, step 1 was you only want variables on the left side, so this constant term's got to go. I'm going to move the 8 over. I'll be left with 9x squared plus 18x, and then negative 8 will be on the other side. And this is actually the first example where we actually have to do step 2. That was step 1. Step 2 is if there's a coefficient of x squared that's not 1, like we have in 9, you have to divide every term by it. So it's not really too big a deal. It ends up being okay. Just an extra step to remember. So that'll leave me with x squared plus, here 9 goes into 18 twice evenly. On the right side, though, you end up with negative 8/9, which isn't too pretty, but not the worst thing in the world. Alright, and then the third step is that's where you're trying to find your magic number. Okay, we're getting there. So remember, magic number is half of the coefficient of x. Our coefficient of x is 2 now. And notice, what if you had skipped step 2? You didn't divide by 9. If you were trying to find the magic number at this stage, you would have used 18, half of 18. And you would get the wrong magic number. So you really do have to do all the steps and in the same order. Don't skip any steps or mix them up, or you'll have the wrong answer. So half the coefficient of x, which is half of 2, and then we'll square the result. Half of 2 is 1, and we'll square that. 1 squared is 1. So it looks like the magic number is 1. We'll add that to both sides, 1 here and 1 here. Alright, and then we'll have what was already there, x squared plus 2x, but now plus that magic number 1, equals the negative 8/9 that was already there, plus 1. And the left side should factor nicely, I think. It's an x and an x. What multiplies to 1 but adds up to 2? That would be a 1 and a 1. Or if we wanted to, we could use that trick that we pointed out in the last example where we said the number that goes in here in the parentheses will always be half of the coefficient of x. Half of 2 is 1. So we could have used that just to practice it. On the right side, we want to combine negative 8/9 and 1. So I'd better put the 1 over 1 and multiply it by 9 over 9. That'll mean I have negative 8/9 plus 9/9 over there. And on the left now, of course, you want to write that as x plus 1 squared. You want to see the same factor twice. If I add the fractions on the right, negative 8/9 and 9/9 is 1/9. At this stage, I always feel home free because now it's just like the problems from the very first example where you're square rooting both sides to solve, and I feel like all my brain power is used up, and it's okay because there's not much left to do. Just don't forget your plus or minus. The square root of 1 is 1, the square root of 9 is 3. So there we are. Now I can solve for x by moving the 1 over. So it looks like my solutions are plus or minus 1/3 minus 1. But they want you to split that into 2 solutions, so I'm going to write one of them with the positive 1/3 and then minus 1. The other one with the negative 1/3 minus 1. And you know what? Those are actually like terms. I can combine those if I get a common denominator on both of those. I'll multiply this guy by 3 over 3, same with this guy. So this one will become, let's see, 1/3 minus 3/3, which is negative 2/3. There's one solution. This guy becomes negative 1/3 minus 3/3, which is negative 4/3. There's the other solution. Whew, that's a lot of work, huh? Look at all those steps we took. Whew. That's a tough one. Alright, but yeah, this, like I said, I think this might be, honestly, maybe the most painful part of this whole class. It's just very tedious, but just know that if you can do this, you can do anything. It's very tough. It's a lot of memorizing the steps, and you have to memorize them in the right order. You can't mix them up. So very tricky. But the more you try, the better you get. So let's try part B here. Remember, if they want the x-intercepts, that means you're taking this function and setting it equal to 0. And then we'll just follow the steps from completing the square. The first step was move the constant term over because you only want variables on the left. 3x squared minus 5x equals 2. And now the second step we have to do again because it says if the coefficient of x squared or the leading term is not 1, like ours is a 3, you have to divide everybody by it. So I'll divide everyone by 3. That'll give me x squared, minus 5/3 x equals 2/3, And that looks bad, and I'm even getting more sad because I'm realizing I have to find the magic number now. And that's going to be terrible because, remember the magic number, it's you take half of the coefficient of x, and ours is negative 5/3. Oh my gosh, that's terrible. Take half of that and then square the result. But remember, if it's something like a fraction and finding half of it's kind of tough, just multiply across. You got 1 times negative 5, that's negative 5, over 2 times 3 is 6. And then you're just squaring that. So you got, well, it's a negative squared, so it's a positive. 5 squared is 25. 6 squared is 36. There it is. So that's your terrible magic number, and that's what you want to add to both sides. It'll be the left side plus 25 over 36. The right side plus 25 over 36. Terrible. Alright, what was on the left side? X squared minus 5/3 x. And now plus that 25 over 36 equals the 2/3 that was already there plus the 25 over 36. And this is where I'm supposed to factor the left side. And we know, you know what, by now, this is going to end up being a perfect square. Because we know this two factors are the same. You might as well write it as that. But remember, the number that goes in here, it's going to be half, like we said before, half the coefficient of x. Which you always have halfway through your magic number. Remember, we found half the coefficient of x here, and ended up being here, negative 5/6. So I'm just going to write that in there. It's like, yeah, kind of halfway through your magic number. Not all the way. You don't square yet. It's right before you squared. The negative 5/6 is what we want. On the right side, I see I want to add 2/3 and 25 over 36, but I need a common denominator. The common denominator would be 36, so I need to multiply the first fraction by 12 over 12. And I'll transform it into 24 over 36, plus the 25 over 36 that was already there. Okay, I better add those before I do anything. I'm just going to rewrite the left side as is. The right side now becomes 49 over 36 if you add those guys. Alright, we're getting there. And this is the stage where I told you guys, I feel home free now. If the left side looks like something squared, then you're pretty much done. Now I square root both sides and solve for x. And don't forget your plus or minus. So the square root of x minus 5/6 squared equals plus or minus the square root of 49 over 36. Okay. The left side, the square root and the square cancel. On the right side, you have plus or minus. The square root of 49 is 7. The square root of 36 is 6. So that kind of worked out well. If I isolate x, I'm going to add 5/6 to the other side. So that'll give me x is plus or minus 7/6. And I don't want to add them yet because the plus or minus represents two different solutions. But now I'll split it into its two solutions and try to figure out what they are. I've got, on one hand, the positive 7/6 plus the 5/6. On the other hand, I have the negative 7/6 plus the 5/6. The left one, 7/6 and 5/6, that's 12/6 or 2. And on the right, I have negative 7/6 and 5/6, that's negative 2/6. But that reduces to negative 1/3. Whew, I like when the answers are nice like that. That's kind of satisfying, you know? Whew. If there's anything satisfying about these problems, I don't know. Whew, you guys, that's tricky. Alright, we got one more, and I think this, probably by this point, it's getting, I don't know, you're not happy about it. It's not an easy task, but it's pretty important. Completing the square will come up, especially if you're a STEM major. You'll be doing this a lot. So it's really good to know, very important stuff. So, okay. Same thing here. If you want to find the x-intercepts like it asks for, you're going to take the function and set it equal to 0. Alright. And then we're going to move the constant term over, because remember you only want variables on the left. That way 4x squared plus 3x equals 5. And now step 2 was, if there's a coefficient of x squared, you want to divide everybody by it. So unfortunately there is. You have to divide by 4 on everyone. I know you're going to have a tough job if it doesn't divide in evenly, like here, 3/4, that's not nice. And here, 5/4 is not nice either. Ah, well. Alright, that was step 2. Now step 3 is you want to find the magic number. So I'm going to go off to the side. And you know, I realize that a lot of times you can find the magic number in your head, but I like to write it out because it's useful. Later on, when you're trying to figure out how it factors, remember halfway through the magic number, you're going to see what goes in the factorization. So it's nice to have it written out. Let's see, the magic number is half the coefficient of x squared. The coefficient of x is 3/4. Alright, and then that one, I can't really think of what half of 3/4 is, so I'll just multiply it across. 1 times 3 is 3, 2 times 4 is 8. And then I'll square that. 3 squared is 9, 6 squared is 64. Or sorry, 8 squared is 64. That's our magic number. So that's what needs to be added to both sides. 9 over 64 on the left, 9 over 64 on the right. There we go. So we'll have x squared plus 3/4 x plus that 9 over 64 equals the 5/4 that was already there plus the 9 over 64. Whew. Alright, and then the left side, we've kind of seen this before. This is always going to factor into a perfect square, x plus or minus something squared. And that something is half the coefficient of x, which you found kind of halfway through the magic number here, this 3/8. That's the guy. That was what half of 3/4 was. So might as well just kind of copy it down. We've already written it out. On the right side, I would like to combine those fractions, but I see that they have different denominators. Let's see, 4 and 64, the common denominator is 64. That means this guy needs to be multiplied by 16, since 4 times 16 is 64. That'll transform that fraction into, what's 16 times 5? 80 over 64 plus the 9 over 64 that was already there. Alright, looking good. I think we're almost home free here. All the hard part's over. 80 and 9 makes 89 over 64. And now we're ready to solve for x all the way. We'll square root both sides. We're getting there. So the square root and the square will cancel from the left. Don't forget your plus or minus on the right. X plus 3/8 on the left. Plus or minus, let's see. 89 does not have a square root and it does not simplify. If 89 was something that can simplify, like, you know, I do the factor tree to break it down and all that, if that was possible, I would do it. But 89, I don't think it's, I think it might be prime. And even if it's not prime, I don't think it has anything that divides in that has a square root. So it's not really worth trying to simplify. Let's see. So, and 64 has a square root, so it's 8. Why did I do that? The square root of 64 is not 64, it's 8. Hello. Now I can solve for x all the way by moving the 3/8 over. Alright, we'll be pretty much done. It's just we're gonna split the solution up into 2 at the end. It's plus or minus 89 over 8 minus 3 over 8. So our two solutions, one's gonna have the positive, so positive root 89. And you know, since these two fractions have the same denominator, you'll probably see them write it as one big fraction like that. And then one where it's the exact same solution except the root 89 is negative since it's a plus or minus. But notice the plus or minus doesn't affect this 3. Only the sign of the root 89 changes from one to the other. Nobody else's sign changes. Alright. This is the toughest section. I would argue this is the toughest section in the whole class. So if you didn't enjoy that, I think you're in good company. Most people feel the same way. And you just really have to practice this on your own. It's one of those types of sections where it's so difficult and just the steps are so seemingly random and it's hard to remember that you just have to keep practicing it until it becomes kind of second nature and you almost accidentally memorize the steps without even trying. But thanks for paying attention. I think you'll like the next section. Don't worry, it doesn't get worse, it gets better. So stay tuned. I'll see you in the next video. Thanks.